Okay guys, so we're on a bit of a manic Geiger counter day today. It's a bit of an aftermath from my weekend of fixing Geiger counters for various different people. So this one that we've got here is actually a DP5A. Now it's a Russian or a Soviet. It's actually the like 1970s, early 70s, late 60s. These were made around, and they would have been used in Chernobyl. You can get them on eBay. There's a guy on there, Roman, and he is under the seller name Any Devices. On eBay he sells these reasonably cheap. The delivery is expensive, but if you ask him, it's actually less to get to this country. That's it, England, by the way, guys. But yeah, real nice Geiger counter. This one was actually bought by Bonus Nudges, or Bruce, my friend from Google Hangouts, and he's usually on Google Plus about the place. He bought this well over a year ago, and he got it from Roman, delivered all the way from Ukraine to Scotland, because Bruce is up in Scotland and Roman's down in Ukraine. So he bought it from him, sent it up to him, and opened the box, turned it on, and nothing, nothing at all. So yeah, so he had a bit of a problem. He talked to some friends at work that could actually translate a bit of Russian. He got a few different ideas and poked around with it for a few weeks, maybe months. But then he was talking to me about it one day, and I said, "Oh yeah, I'll take a look at that." So he sent it down to me, and when I got it, first thing was to work out the batteries for it. So it takes really weird 1.5 volt cell batteries, but they're really strange fat batteries. They don't actually make them anymore, a bit obsolete. You can buy them, but they're like 20 quid each, and you need, what is it, 3 in there. So bit of a problem. So I was kind of hooking up like 1.2 cells and things like that to it, but it wasn't working out too well. So I gave up for a while. Then like a couple of months later, I gave it another try. Nothing much, but about about a year later now, I was poking around a bit this weekend, and well, just poking around at the components, looking through the schematics and things, just following it a bit. And I just put it back together. I thought, oh, what the heck? Just try it on, see if it's doing anything now. And bzzz, it makes this funny buzz sound. And yeah, it was actually working. So I got a source, a radiation source like that one there. Quite a powerful source that is, pitch blend. Put it near the probe, and hey presto. So yeah, it actually works. So it did take me a while to work out exactly how to use all these dials and things, but I'm pretty sure I'm competent on that now anyway, which is cool. But yeah, I'll give you a demonstration of that, guys. So if I turn on the power supply for it, yeah, I've got a dual output power supply I'm running it on now. I have upgraded to that, so I've got a dual output power supply I can turn on now. Okay. And then all I need to do now, just twiddle it up a bit, right. So I put it onto. Yes, you might just be able to hear that whistling if you listen ever so carefully. It's like making a high-pitched whistle. So now what I do is I tweak up this dial until it reaches the little marker up in the corner, top right hand corner, just up, that little marker there. So I'll tweak the dial, hear the frequency changing, right up to that little triangle. About there, that's about right. Tongue at the right angle, as Dave Jones would say. So what I do now is I set it to its most sensitive setting, so that's all the way about around to times 0.1, which is actually down here, times 0.1. So I'll turn it around. Quite a stiff, it's hefty. I tell you what, this thing is built to be handled by brutes, it's freaking heavy duty. Right, so that's getting a bit of a source. If I put the source near it now, so I've got the pitch blend, and I'm not sure if you'll be able to hear it. I've got the little piezoelectric speaker hooked up to the microphone port on the side there, so, sorry, not microphone, headphone port on the side there. So if it's connecting it properly, it should get a reading when I put it near. Anyway, so you'll see the dial go up now. Get the focus, there you go. So it's climbing. It will vary depending on how close I stick it. This is a gamma source, by the way, guys. So I've got the window closed on the probe. I'll show you just quickly. That's for gamma, and you turn the probe around, and that's for alpha beta, which is quite cool. Go shut that little window there, you can just about see it. But we're set on gamma today because we're just measuring the pitch blende, which is a gamma source, which is a uranium ore, in fact. So I'll stick that there, and there you go. We're actually getting a reading now, and it will vary depending on how close I stick the pitch blende to it. For example, yeah, it's climbing. It takes a little while to respond. I've noticed the little speaker not quite working. There you go. Come on. There you go. So that's clicking away now. That's just a little piezoelectric I had lying around. Just stuck them in the prongs there, and there you go. So yeah, it's working pretty good, as you can see. I do have some more sensitive actual samples, but they are over there a little bit. But yeah, I can put this a bit further away, and you'll see it decrease on the dial there. It's going down a bit, but yeah, it works, which is nice. Very good. The only thing is that it was a loose connection, but I didn't quite know where. So there's a chance it might actually come loose again, which is a bit of a problem, really. But just a matter of when and if it does, and I don't know. Probably just fix it again. Maybe use the persuasion hammer. Maybe not. But yeah, that one worked. So after fixing that one, since I was on a roll, I thought, oh, this is good. I decided to look at another one that my friend actually sent me, which is this one just here. And this is a Model 1, British Army Model 1. It's actually a trainer. So what this one is used for is they give it to soldiers for training purposes, and they'd use it. And this is basically the very sensitive one. This is the one that measures the, it'll measure pitch blende quite easily, and obviously once they're competent using this, then they can move up to a model number 2, which is the much more, the much less sensitive one. It's about 1,000 times, I think it's either 1,000 or 10,000 times less sensitive than this one. So obviously if they made a mistake with that, if they see it read 0.1 on it and they haven't got a radiation suit on, then they probably either shouldn't be there or they'd already be dead by then, possibly. But yeah, if I show you that one running, this one is different. This one runs on 4 30-volt batteries, and it needs a 1.5 volt also to run, which is weird. But yeah, so 4 30-volt batteries adds up to 120 volts DC, and you cannot buy those batteries anymore. They are obsolete. You can buy something similar, which is about half the size, and you can parallel them up and then just put them in, but they're about 20 quid each, and then you need 8 of them, so no chance. So what I've done is literally just jury-rigged up a quick little DC power supply. You can probably just see the rectifier behind there, and then the capacitor, or the condensator, just there, and we got the little lamp there, which is just going to drain the capacitor when we turn it off, and obviously warn us that there's voltage there. So yeah, if I just turn that on, I will need to turn on the 1.5 volts first. That's the power supply for the 1.5. There we go, it's running. Alright, I'll zoom this out a bit. You might be able to see it start, possibly. So I'll set this on DC. So we're measuring the voltage of the capacitor now, just to make sure we don't go over range. We want 120 volts DC. So I'll just turn the variac on, the little 402 LAB. That's 3 volts at the moment at 0. So I'll just crank it up. 20, 30, 40, 50, 70, 80, 90, 110. I'm not sure if you can see the little lights come on there. And 120. Ooh, not too far over. Gotta be somewhere near. So there you go, it's about 120 volts DC there. Right, so now as you can see, we got the dial is lit up because there's a little neon light there, and it's measuring background at the moment. Not sure if you can see that. Just move the light over a bit. There you go. So it's now measuring. If I move you guys over a bit, you'll be able to see. Right, now if I take the pitch blend sample from this one, you'll hear that one stop clicking now. There we go, pitch blend. Quite cool stuff. It's probably my most potent sample really, and that's uranium ore is all it is really, and it's a nice gamma source as it says on there. That's all it looks like. Just looks like a bit of average rock that you find anywhere, except for it's a bit more special, this one. So yeah, that's probably my most potent source of gamma. It's not really that, you know, it's just these meters are quite sensitive. You won't want to eat it basically. So what I'll do is I'll put that near, as you can see there's a Geiger Muller tube over the back in the middle there of the meter. So if I put that at the end of that, over there, then you should see that'll start climbing. There you go, it's getting there. It's getting a little sweet spot. Let's see about there. There goes a sweet spot-ish. Climbing, get it to about 1 roentgens per hour times, what is that, 10 to the power of -4. That's an unusual way to measure it, but yeah, I prefer sieverts. Well, it's metric nowadays. Mine, this meter was made in the 1950s, so yeah, you can appreciate that they had different ways of measuring things back then. But yeah, if I move it closer and further away, it'll change. Just holding it over the back there. Obviously, careful not to touch 120 volts DC, because that will be pretty painful. And there's also some high tension, some high voltages going on inside this Geiger Muller tube and inside the power supply for it there. So that's pretty cool. So yeah, just take it away and you can see it ramp back down. So yeah, that's another one, and that was literally, it's just, that one wasn't actually broken. That was just a matter of hooking up some sort of DC power supply to it. Did take a little bit of working, as it won't run without the 1.5, which is the middle terminal there, 1.5 volts DC. You have to have that one connected, otherwise it just won't measure anything but background apparently. It will just stay where it is now, which is weird. But yeah, very well made. I won't be touching that now, guys, but yeah, it's very well made. These are both wide and similar point-to-point type circuit board construction. There's no actual traces on there. It's literally just little tacks there, and then they just wrap them around, solder them on to the next point, and then it goes through to the other side of the board, and they just keep doing that, and then just wire it up with little looms everywhere, and that's it. So yeah, real old school construction, but works really well. As you can see, there's the arm there that sets the range on here, which is the little top bit where it says 0, 1, 2, 3. That'll go to off, and it's also got a 0 position, which I haven't worked out how to use that yet. Only got this running yesterday, so I'll have some time to play with that soon. But yeah, that's that one done, and I have another one here. This is my own, this one here. This is a really sensitive one. That is a mini monitor series 900, and that's probably the most sensitive one I have. And if I just turn that one on now, got a battery. The battery's getting a bit low on there. It gives about 10%. So if I put that on, there you go, it's ticking away. Right, you'll be surprised how sensitive this is, because I'm just about to get the pitch blend, which is that guy there, and I'll stick it somewhere near. Don't forget it's a pancake, this one, and I'm even holding it that far away at the moment. Well, I'm not even over the top, I'm right in the foreground, so if I take it somewhere near, you get an idea. Whoa, saturation. Yeah, about 200 counts per second on that. So yeah, that's pretty potent, but don't forget that this is also a very sensitive meter, this one, because he's got a pancake probe on the back there, as you can see. Just put this down so it unclips, and that is basically a very sensitive probe, because it's got a huge surface area, as opposed to these ones here which has just got that little tube in there. This has got that massive surface area. So this one I'll actually measure bananas, like radiation and potassium, which is found in bananas, funnily enough. But yeah, you put it anywhere near, and it nearly goes off the scale, which is cool. That's quite handy. So yeah, that'll come in very handy for whenever you're measuring any of your radiation sources or playing around with bits and pieces, or maybe even these guys up here, like that X-ray tube up there, which you can see, reasonable size I guess if you compare it to those E40 bases there, or the grenade fire extinguisher, which is a functional fire extinguisher just in case. It's always safe to have a fire extinguisher in your lab. Or even, if you want to go bigger than that X-ray, then maybe even one like that. And yeah, that is A4 sheet of paper just below there, by the way, guys. So the bazooka, I call that, the bazooka X-ray tube. So yeah, probably wouldn't want to be firing that up, to be honest. That's a pretty potent X-ray tube, which is actually made by General Electric. I discovered the other day when I was polishing it. Discovered there's some writing on it. That writing there is actually a reflection off the back of there's a box. There's my sample source box over the back. But yeah, probably won't want to be running that up. But that's a nice centerpiece, I guess, for probably a bit heavy from the shelf. It weighs more than God. It's got to weigh about, what is it, 15 kilograms, maybe more, maybe 20. Literally a bazooka. So yeah, proper job. Yeah, no half measures, no half measures. Right, so I think that'll draw an end to our Manic Geiger counter session, guys, and radiation everywhere. And I'll have to remember to take my iodine tablets. Probably should have taken that before, but I'm joking, guys. But, I'll turn off that 120 volts. That's probably a good idea. You'll see the old light there just ramp down. It's always good to be safe. I like using lamps because of the fact that you can see obviously that there's voltage there because it's lit. Unless of course the filament actually blows, but hopefully you know about that when you start looking at voltage on your meter and not seeing it actually glowing on there. But yeah, it's a pretty cool way of doing it. Should get a red one really so you can see danger voltage. And I'll turn these other ones off now, so that's the noisy one, that is. And the other little Russian one there, just clicking away quite happily, stretching its dials for the first time in probably many years, because that has never ran in its life probably since it was made. You know, these were made in Soviet Russia, and they made so many of them, but no one ever used them, and they just sort of like just put them in boxes, and I don't know, Roman got hold of them and he just decided to list them up on eBay. So yeah, they're pretty nice. New old stock really. So yeah, if you want to get hold of one of those guys, I know I will be as soon as I'll be sending this back to Scotland for Bruce there. You know, he'll be I'll be pretty missing it. You know, it is a real nice meter. It's one of my favourites. That is quite quirky. It's got that sort of like what is it, Art Deco 1930s radio to it. So pretty cool looking. So yeah, I'll turn that off. Arrange down, clickety click. That is it. God, there's a lot of ranges on that. It's by far the best for diversity. You know, that can measure really powerful sources, or it can be really sensitive at the same time, which is far superior to that one, which can only measure really sensitive, and that one there, which can only measure really sensitive. But of course, you can put things in front of the probe and to measure gamma only and stuff like that. But yeah, depending on what you want to do. So turn all the power supplies off, and yeah, so I'll just wrap it up, guys, and I hope you all enjoyed. And I think we'll be following this up sometime in the near future with some more Geiger counter type stuff, because it is high voltage, as you all know. GM tubes do contain high voltage, which is cool. So yep, hope you all enjoy, guys, and I'll see you all again. Cheers, bye.